Hello and welcome back. So I have to admit, I think I lied to you. In my last video, I said that we were going to begin working on our online multiplayer game. But the truth is, we're not. We just can't do it yet. There is one more crucial thing we must learn before we can write a multiplayer game. And that concept involves dealing with an item that we have simply glanced over up to this point in the course. That is our maximum byte size that we can use to send data through our socket data stream. Up until now, we have just set it to 1024 bytes. We forgot about it and we have been happy. But now, working with a game, I want to give more attention to how we are going to handle the size of our packets that we send through the data stream to help ensure that all of our game data gets to where it needs to be. To help accomplish this, we're going to introduce the concept of packet headers. So I'm going to open up two new files, and I'll save them as, we'll call them headers server and headers client. So let's see, we'll open one here, I'll save it, and we'll go to my directory. We'll save it in the multiplayer game, and we'll call it headers underscore server.py. And I'll open up another one, new file, text file, and save this as headers underscore client.py. Okay, perfect. So we'll just say an intro to using fixed length headers, and I'll say this is server. We'll copy that, and I'll just paste it over on the other side. I don't know. I always like to put an intro comment, so we'll say client. Okay, perfect. So here, what we're going to do is let's start on our server side, and let's just whip up a really quick, socket connection. So we'll say import socket. We'll create a socket. We'll do server socket is equal to socket.socket. And inside of here, what kind do we want? We want socket.af underscore inet and socket.sockstream. There is our, spell stream right, that would be good. So there is our IPv4 and TCP socket. We'll bind it, so we'll say server socket.bind. And at what? So our tuple is going to be socket.getHostByName. And inside of here, we'll pass socket.getHostName. And then we'll put an arbitrary port of 12345. That's our port number we've been working with. And now we'll listen. So server, did I do socket? I did socket there. Sorry. Server socket dot bind. And now we'll do server socket dot listen. Okay, perfect. Now let's make a couple of messages here that we're going to try to send through our data stream. So say message underscore 1 is equal to hello, we are learning more about sockets. All right, and message 2 will read goodbye. Goodbye. Now we know about headers. So those are going to be our two messages that we are trying to send. So now let's listen for incoming connections, and we'll try to send them. So we'll use an infinite while loop here. So we'll say while true. We'll just put a comment accept connections, and let's accept any connections, and we'll get their information, and then we'll print some confirmation to the server. So we'll get the information that comes through when we accept a connection, the client socket and the client address, and that's going to be our server socket.accept. So we'll accept any incoming connection, accept. There we go. Now let's print. We'll just print some confirmation. I'll use an F string here, connected to, and then we'll say client address. I always like to do that. Gives a little bit of just confirmation on the server side. Okay, perfect. So now I'm going to put my little comment here. Let's say let's try to send two messages. So let's try to send message 1 and message 2. These are simply strings, so we don't have to use any JSON. We're just going to encode them and send them along. So we'll grab our client socket that we connected to us, and I'll say client socket.send, and we'll do message underscore 1 dot encode, and we'll just use UTF-8 here. All right, and then we'll do client socket.send. We'll send our second message, message underscore 2 dot encode, and we'll pass an encoder of UTF-8. So just really quick. Perfect. So that looks like it's a pretty good server-side script. So I'm going to save this, and let's go look at the client side now. So let's head over to the client, and we'll import socket again. So we'll import socket, and we'll create create a socket. We'll do a client socket here. So we'll say client socket is equal to socket.socket. And then socket.af underscore inet for IPv4 and socket.sock underscore stream for TCP protocol. So now we'll connect. So we'll do client socket.connect. And where do we want to connect? Well, we want to connect to our local IP. So socket.get host by name. And in here we'll do socket.get host name. Awesome. And what port number? Port 1, 2, 3, 4, and 5. All right, so now when we connect, we know we're going to receive some messages. So let's receive the messages with an arbitrary max byte size, just like we have done before, except this time, let's use a really small number. Let's use like 8. We know it's going to be way too small and it's not going to work, but let's just do it anyway for learning. So we'll say let's receive 2 messages with a small byte size of 8. Will not work. So we'll do message is equal to client socket dot receive. We'll put a max byte size of 8, and then I'll print the message dot decode, and we'll pass in UTF-8 as the encoder here to decode. And then I'm just going to copy this, and I'll override the variable message. That's fine. So then we'll grab the message again, and we'll print the message. So let's run this, and let's see what happens. We know it's not going to work. So let's run the server. All right, server's running perfectly fine. Let's run the client, and let's see what we get for our messages. Socket has no. Oh, I spelled stream wrong here. My bad. Let me fix that. Sock stream. That's a tough word to spell, I suppose. All right, so let's try it again now. So hopefully now we'll be able to connect. Oh my goodness, I'm moving way too fast. I spelled client socket wrong here. I forgot my E. Let's try third time is the charm. I think that's a phrase. So let's try it again. Perfect. So now if we look, look at our output. So we have hello, comma, space W, and then ER. That makes no sense to me, but it actually does, because what we're getting is we set our maximum byte size to 8. So that means our packets, the largest packet you can receive through the data stream, is 8 bytes. Well, look at here. 1, 2, 3, 4, 5, 6, 7, 8. There are the first 8 bytes, and so that's hello, comma, space W. And here are the next 8. Here are the next 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're only getting like a small portion. All of this was left in the data stream, and our entire second message was still left in the data stream. So this clearly isn't working because there's more data that we have to get on the client side. So what did we do? Well, we previously accounted for this by just setting our arbitrary, byte size to be much larger, like 1024, and that worked. So I'm just going to copy this. I'll copy this whole thing, and let's just paste it. So we have kind of like an outline of what we're doing, and I'll just kind of I'll use a doc string to do a multi-line comment here, so that this isn't going to run. And let's change our max byte size to 1024. 1024. And so let's receive 2 messages with a large byte size of 1024. And we'll say, this will work for now. Okay, for now. So let's see. Let's just verify. It's the same thing we've been doing, so it should work. If it doesn't work, I will be sort of startled here. So if we run this now. Okay, it says, hello, we are learning more about sockets, and then goodbye, now we know more about headers. Awesome, so this worked excellent. We received each individual message whole, no problems. A clear issue though, right, these are small messages, these are just strings, but what if we had to send something that was larger than 1024 bytes, maybe something like a dictionary that holds data for an entire game? Well, then this would fail just like it failed when we had a max value of 8 bytes. So this really isn't that great yet. There is another issue though. And so let's see what happens if we add some delay time between the client connecting and us receiving the messages. So we're going to add some time variability into our program. And we can do that with the time module. So I'm going to come up here to the top, and where we're importing socket on the client, I'm also going to import time. So now let's see. I'll put a new comment here. Let me multi-line comment this out. Fake multi-line comment, right? I don't think it's an actual multi-line comment. So we'll say what happens if we add some delay time in between the client connecting and trying to receive messages. All right, so we'll call our time module that we just imported, and we'll call the sleep method, and we'll pass in a 2 here. So that will sleep for 2 seconds. And so now I'm going to just copy this. So we're going to run the exact same code where we'll grab a message and we will print it, and then we'll grab the message again and we'll print it. And then I'm going to put one more print statement. And this printment will say, why isn't this printing? All right, with a bunch of like question marks here and exclamations. So let's run this now when we introduce some time variability into our programs. So we'll run this. We're still just sending our 2 messages over. All right, our server's running. And so now when I run this, we'll run our client. Let's see what happens. So if we look, you might say, okay, well, maybe this worked. Did this work, though? I think the answer is no, because if you notice here, our last print statement is not printing. This like, why isn't this printing? Isn't printing. And so you might think to yourself, maybe our program is hanging, and it kind of looks like it's hanging right here. And it actually is. Now, do you notice our 2 messages that we received are on the same line here? They were sent to the data stream through our socket as 2 individual messages. Okay, so we sent our first message into the data stream. We sent our second message into the data stream. So they're up there, and you know they're good size. I'd probably say this is like 42. I think this is 42 characters, and this is maybe like 30 characters. So we'll say it's like 72 characters long, 72 bytes of information. And what's actually happening is when we add the variability of time here, when we call this receive method right here, we're looking into the data stream, and our first message is only like 40 bytes. It's way smaller than our maximum byte size of 1024. Add our second message to it. Now it's only like 70 bytes. It's still smaller than our maximum byte size of 1024. So what's actually happening here is this single call is grabbing everything that it can out of the data stream, and it's putting it all here as like one individual message. And so now we print that message, and when we try to receive something from the data stream again, nothing's there. And so the program is literally just hanging right here, waiting to receive another message. And that message isn't coming in from the server, so nothing else is going to run. So this is really bad. It's like program breaking bad, and it's the types of problems that are really difficult to debug. So we've seen some pretty glaring issues with using just an arbitrary, maximum byte size of like 1024. Let's summarize them down here at the bottom, just for like learning purposes in our client. I'll do it as a comment. So I'll say we might not know the maximum byte size of the data being sent. It may be more or less than 1024. So we'll say 2 issues moving forward. Number 1, if we are too small with our byte size, we'll have issues not getting the full data packet being sent. So we saw that, right? If our byte size is too small, we're not going to get the full data packet being sent. Number 2, if we are too large, it's kind of like, Goldilocks, too hot, too cold, just right. If we're too small, if we're too large with our byte size, and there is a time delay between sending and receiving, we might get more than, I'll go to another line, more than one data packet being sent in a single .receive call, which is bad news. And so we'll just mention here's the big issue. We can say we can fix this by first receiving a header of fixed length that will give the size of the incoming message packet. And that is the idea. So anytime we are going to send a message, we're first going to send a header of fixed length that will inform the client or the server how big the next message packet is going to be, and we'll use that value for our maximum byte size. So I think this is a good place to stop. In our next video, we'll talk about how we implement these headers of fixed length. So I will see you then.